All right, in this tutorial video, what we're going to practice is simplifying radicals as well as conjugates and rationalizing. So to start, we're only going to do the odds on this practice because the evens are just like the odds, and there's 43 problems, so just for your sanity, I'm just going to work the odds. The answer key is fully uploaded on our Google site, so you can make sure that you find it there if you're doing the evens and would like to check your work. Also, if you would like any explanation on the even numbers, just let me know. I can work out any of these problems for you, but just for sake of time and repetition, we're only going to do the odds. So let's go ahead and get started. We are simplifying the square root of 125n. So I'm going to use this little cheat sheet that's got all these perfect squares on it. Hopefully, eventually you'll have these memorized. But what I'm looking for is perfect square that I can pull out of 125. So let's say that I don't know my perfect square. Obviously, it's 25. But if you don't know that, the way that you use this little chart is you have 125. You find the largest number that is less than 125. So my answer up here is 121. All I'm going to do is just start dividing 125 by these perfect squares until I get a whole number. So notice we got a decimal when we divided 121. We got a decimal when we divided by 100. If I hop down to 81, we get another decimal. Hop down to 64, decimal. Hop down to 49, decimal. 36, decimal. And then when I type in 25, I get a whole number. So that means 25 is the perfect square that is hiding inside of my square root. So I can break up 125 into the square root of 25 times the square root of 5. So these two numbers that are here and here, those, the 25 is my perfect square and 5 is what's left over. Now we can just simplify. Well, the square root of 25 is 5, and underneath the radical we have 5 as well as this n value that's just along for the end. Okay, let's try number 3. So again, I'm going to test my perfect squares. This number is 512, so I'm going to start all the way at 400, so I'm going to do 512, and I'm just going to start dividing. Let's see. So I'm just dividing by the perfect squares. As you do these, this becomes a lot easier, and I'm actually not going to be doing these like the repetition of typing all of these in over and over and over because I want to save us time. So I get 256 and 2 with going into it, so that means I can break 512 into 256 times 2. So the square root of 256 is 16. So my 16 is outside of the square root. Inside my square root, I have my remaining 2. Now I have k squared, so I want to think in groups of 2. So the square root of k squared is just k, meaning the k value comes out. Okay? Or you could think of 2 divided by 2, because my index here is 2. 2 divided by 2 is 1, so I have a power of 1 out here with a remainder of 0. Next one is 216. To simplify 216, I'm going to go ahead and try 36. Again, the goal of this is just repetition. It takes time to learn the factors, and I have the answer key next to me, so don't think that I'm like doing these off the top of my head. You can always use this little cheat sheet. You just start. So if I was going to use this chart, 216, I would start using 196. Because I can't go over 216, so I can't use 225, and then I would just continue down until I get a whole number. So this is going to break up into 36 times 6. So the square root of 36, remember these are both under square roots, square root of 36 is 6 with a 6 left underneath. Then I'm going to continue to simplify. I have the square root of 4 squared, or k to the 4, I don't know what I was thinking there. So how many groups of 2 can I pull out of k squared? Well, 4 divided by 2 is 2, so k squared. All right, this next one, number 7, this one has a number out in front. What we're going to do is kind of ignore that number until the end. We're just going to pretend it's not there. So I'm going to break 216 up again, same problem as up above. 216 was 36. You'll see a lot of repetition, so 36 times 6. The square root of 36 is 6. Okay, I'm going to bring my square root. My 6 stays in, so this 6 comes down. 2 divided by the index of 2. 2 divided by 2 is 1, so x has a power of 1. 2 divided by 2 is also 1, so y has a power of 1. And my z only has a power of 1 here, so 1 divided by 2 is a decimal. So my z value, so I'm not to write x there, just cross that out. My z value will stay underneath. Now to finish this problem, I need to make sure I distribute, so negative 4 times positive 6 is negative 24xy square root of 6z. All right, let's try the next one. Again, 3 along for the ride until the end. The square root of 16, we should recognize that as a perfect square. The square root of 16 is 4. Then underneath my square root, 4 divided by the index of 2. 4 divided by 2 is an even number of 2. So x has a power of 2. Y to the 4, 4 divided by 2, again, is 2 with no remainder, so y squared. And z is to the 1. 1 divided by 2 is a decimal, so I'm going to leave z underneath. To complete this problem, I'm going to multiply 3 times 4, which is 12. X squared, y squared, square root of z. Number 11, again, the 6 is just kind of there. 75, hopefully you know that 25 times 3 is 75, so 25 is my perfect square. The square root of 25 is 5. 3 can't go anywhere. M only has a power of 1, so when I do 1 divided by 2, I get a decimal, so M stays. P is 2, so 2 divided by 2 is 1, so P goes to the first power. Q is 3, so Q to the third. 3 divided by 2, so 3 goes into 2 one time with the remainder of 1. So if you don't see that, you can always do this. You can break it down into Q times Q times Q. When you square root, you're looking for doubles. So when I pull out the double of Q, I would be left with Q. And then this Q stays inside, which is exactly what happened here. Next, I'm going to multiply. 5 times 6 gives me 30 PQ, square root of 3MQ. All right, next one, 192. 192 can be broken up into 64 times 3. So I'm going to keep the negative 4 out. The square root of 64 is 8. The 3 cannot move. The square root of just plain x, remember this has a power of 2, or an index of 2 with a power of 1. 1 divided by 2 is a decimal, so x stays inside of the square root because I cannot group 2. Negative 4 times positive 8 is negative 32, square root of 3x. So whenever you're simplifying square roots, all you have to do is pay attention to the perfect squares. Use this chart if necessary. We wrote this down in our notes, but use it if you need it. And then you just divide using your calculator. So look for the perfect squares. All right, let's try rationalizing. So we're going to do problems 15 through 29, and we're going to be working again on just the odds. Remember, the reason we're doing just the odds is just to save us time because these problems are very repetitive. And also the answer key is posted on our Google site, so just a reminder. All right, to rationalize. Rationalizing just means that there's a square root in the denominator, and we don't want that. So whenever we do problems like this, we don't write square roots in the denominator. So what you do is you multiply by the square root. So my square root is 5. This fraction is technically just equal to 1. So we're not actually manipulating the numeric value of the fraction. All we're doing is manipulating its appearance. We're just making it look different. Mathematically, our rationalized answer and our original answer, they're going to be identical, but we just want to change its appearance. So you always multiply by what the denominator is, so the square root of 5. Then you simplify. 5 times the square root of 5 is just 5 square roots of 5. Basic problem. Now, where the math comes in that you don't really see, the square root of 5 times the square root of 5 is the square root of 25. Well, the square root of 25 is 5. So this is what we write here. This is kind of in the background in our minds. Also, you could think of just the square root of 5 quantity squared. So if I had done the square root of 5 squared, square roots and square roots cancel, and you would just be left with 5. So it's your choice how you want to think and envision this in your head. I like to think of it this way, but this is also an option. Now we're going to look for simplification. I see 5 over 5. Well, those can cancel, and my answer is just square root of 5. Let's try the next one. Again, bottom is square root of 3, so I'm going to multiply the top and bottom by square root 3. Numerator times numerator, denominator times denominator. 6 times square root of 3 is 6 square roots of 3. Mathematically, what's happening in the shadows? Square root of 3 times square root of 3 is the square root of 9. The square root of 9 is 3. Okay. Now I can reduce 6 divided by 3 is 2 square roots of 3. So I can reduce this here, leaving us with no fraction and just 2 square roots of 3. Now, if you don't believe me that they're the same, let's just go ahead and do it just for the sake of explanation. So 2 square root of, 2 square root of 3, this is my decimal. If I type in my original 6 divided by the square root of 3, we literally get the same thing. These are the same answer, just one is not proper math, okay? So just be mindful, we're just changing an appearance, we're not changing a value. All right, square root is 7, so I'm going to multiply top and bottom by square root of 7. 2 times square root of 7 is 2 square roots of 7. Again, underneath I have the square root of 7 times the square root of 7, which is the square root of 49. The square root of 49 is 7. I can't reduce 2 and 7, so this is my final answer. Okay, number 20 is a little tricky. We didn't do one like this in your notes. If you have a number out in front here, all you're going to do is multiply again just by the denominator. So just the square root of 20. Square root of 15 times the square root of 20. 15 times 20 is 300. Hopefully you recognize 100 can be pulled out of there, so we're going to have to simplify. All right, the 5 is along for the ride. Then I'm left with the square root of 20 times the square root of 20, which is the square root of 400, which is just 20. Hopefully you're noticing the pattern. Let's go ahead and simplify our radical here. So 300, I can break that up into the square root of 100 times the square root of 3. The square root of 100 is 10 square roots of 3 over 5 times 20, which is also 100. I can simplify this fraction. 10 over 100 is the same as 1/10. We don't write the 1, so we're just going to leave the square root of 3 over 10. All right, next, square root of 27. Okay, let's go ahead and simplify the square root of 27. So then 27 can be broken up into 9 times 3. And if you didn't recognize that offhand, it's totally okay. So I'm going to go ahead and just write this as the square root of 6 over 3 root 3. This will just kind of save us some time because we've already simplified our radical. 6 times 3 is 18. 3 is along for the ride. Square root of 3 times square root of 3 is square root of 9, which is 3. The square root of 18 can be broken up into the square root of 9 times 2. And I'm just writing it above there just to kind of pay attention to my math and be mindful. Square root of 9 is 3, square root of 2. 3 times 3 is 9, and hopefully I can see 3 over 9 reduces to 1/3. So I'm left with the square root of, definitely not that. I'm left with the square root of 2 over 3. Okay, these problems are getting a little bit more challenging, but again, nothing you can't handle. I'm still going to multiply by the square root of 21. That cannot be simplified. So square root of 21, square root of 21. However, now I need to make sure that I'm distributing the right way. So right here, this is in parentheses. I'm going to do the square root of 10 times the square root of 21, which is the square root of 210. 10 times 21 is 210. Then I'm going to do minus. The 10 can go nowhere. 7 times 21 is 147. All over 2 times, again, square root of 21 times the square root of 21 is, let's see, actually, because off the top of my head, I don't know. 21 times 21 is 441. So we have the square root of 441, which in turn simplifies to 21. To simplify this answer, I'm just going to multiply 2 times 21, so I kind of ran out of space, so I'm going to do square root of 210 minus 10 square roots of 147 all over 42. And there's nothing we can simplify. We can't simplify 10 and 42 because there's no value in front of the 210 that we can simplify. Also, there's no perfect squares hiding inside of those square roots, so we're done. All right, let's continue on to 27. Again, these are just getting slightly more challenging, but it's nothing that you can't handle. This math is the same. The pattern is the same. All right, so underneath here, again, I'm going to distribute 3 times the square root of 34 is 3 square roots of 34. Minus 4, because I cannot simplify this, 7 times 34 is 238. Again, you can do this on your calculator as you're typing. I just have the answer key, so for sake of time, I know that you can do 7 times 34 in your calculator and get that answer. All right, we're going to continue with the 6. It's along for the ride. So now we're going to have the square root of 34 times the square root of 34, which is 1,156. But when you square root that, guess what you get? 34. I'm sure we're all surprised here. There are no perfect squares hiding in 34 or 238. So our final answer is 3 square roots of 34 minus 4 square roots of 238 all over 6 times 34, which is 204. There are no common values between 3, 4, and 204, so you know that you're finished here. Okay, let's try the very last problem before we do conjugates. Again, same level of difficulty as before. I'm going to multiply the top and bottom by the square root of 26. So square root 26 over the square root of 26. Oh my goodness, I'm messing up all over the place. Of course my whiteout is on the, oh, there it is. That was on the other side of the room. Here, we'll just get rid of all that, pretend it's not even there. There we go. All right, again, we're going to distribute. So top, so I'm going to do 7 times square root of 26. So 7 times the square root of 26 is 7 square roots of 26 minus 5 times 26. The square root of 5 times the square root of 26 is 130. Again, my pattern is the same. 4 is along for the ride times 26 times 26 is 676. So when I square root 676, you best believe I'm getting 26 as my answer. So to finalize this problem, I can't simplify 26. I cannot simplify 130. So my answer is just, let's write it over here since I'm not working the evens. 7 square roots of 26 minus square root of 130 all over 4 times 26, which is 104. So the things that you need to remember when simplifying radicals or rationalizing, just multiply by the denominator. As you multiply by the denominator, if you have a plus or minus in your problem, you'll have to distribute. Remember, multiplying underneath radicals, look for simplification. It's nothing that you can't do. You can do all of these problems. They might take you a second to get the hang of it, but once you learn your perfect squares, this becomes a whole lot easier. All right, let's do conjugates. We are on a roll, guys. Multiplying by the conjugate, you're hardly going to see this on the ACT, but I do want to make sure that you have seen it, okay? There's nothing wrong with learning something that you might not use every single test, but the difference between this problem and simplifying by rationalizing, and let me go ahead and just pull up that example. So here is number 15 that we did. Here's 31. Notice how in the denominator you only have a square root or you only have multiplication in your square root, like on your denominator. Whereas here, the square root is separated by a plus or minus, which means you have to use what's called the conjugate. So to do that, you are multiplying the top and bottom by the opposite of what you see. So this becomes 5 plus the square root of 2. 5 plus the square root of 2. Okay, so one thing I want you to make sure that you know is when you're simplifying here, okay, simplifying with conjugates, it's the opposite. You're basically doing the difference of squares, which we talked about in class. You're going to distribute, so let's talk about the top first. 2 times 5 is 10. 2 times the square root of 2 is 2 square roots of 2. Now, the bottom is where it gets tricky. All you do is multiply. 5 times 5 is 25. Basically, it's 5 squared. Okay, so 25 is going to go first. That's how we get this number. Next, We have the square root of 2 times the square root of 2, which is basically the square root of 2 squared, which is 2, which is how you get this number. Now, the sign in the middle is always subtraction. It's basically like a difference of squares, okay? Because the plus and minus, the middle term is always going to cancel forever and always. Now we're going to simplify. Well, I can't do anything with the top. Can't simplify any of those square roots. And 25 minus 2 is 23. So now that I'm looking at 10, 2, and 23, nothing I can do to simplify that, so I'm just going to leave it. All right, let's try the next piece. Again, like a difference of squares, I'm going to change the sign to positive. So I'm going to multiply the top and bottom by 3 plus the square root of 5. Then I will distribute across the top. 2 times 3 is 6. 2 times positive square root of 5 is positive 2 square root of 5. Underneath, again, 3 times 3 is the same as 3 squared, which is 9, which is my first term. To get my next term, I have the square root of 5 times the square root of 5, which is the square root of 5 squared, which is 5. Or if you're thinking of it like this, you could also think of it as the square root of 25. Both of these are identical. So 5 is going to go here. Right here is always going to be a minus. So what I'm going to do from here is simplify. 6 plus 2 square roots of 5 over 4. Looking at all these terms, I can pull a 2. 2 is my GCF. So 6 divided by 2 is 3. 2 divided by 2 is 1. 4 divided by 2 is 2. And that's how you simplify. We pull a 2 out here. On the answer key, which is online, I wrote down the value that I pulled out. I just didn't show it. Okay, continuing on. This one is a little trickier because we've got multiple square roots here. So that's okay. The math process is the same. That's the great thing about math, is this process is identical regardless of what's there. All right, now I'm going to multiply the top. 3 times square root of 2 is 3 square roots of 2. 3 times negative square root of 5 is negative 3 square roots of 5. Then underneath, it gets a little tricky, just like before. Square root of 2 times square root of 2 is the square root of 2 squared, which is 2. So that number goes here. Square root of 5 times square root of 5 is the square root of 5 squared, which is 5. In the middle is always minus. Now I'll simplify. I get 3 square roots of 2 minus 3 square roots of 5 all over negative 3. Sorry, we kind of going into this problem over here. Now I can pull out a negative 3 from everything or a positive 3. I'm going to choose to pull out negative 3. So when I do that, 3 divided by negative 3 is negative 1. Negative 3 divided by negative 3 is a positive 1. And negative 3 divided by negative 3 is a positive 1. So we are finished right here. All right, next problem. Again, looks more intimidating, but the level of difficulty is identical to the top. So negative 3 plus 3 square roots of 3. Negative 3 plus 3 square roots of 3. You only change the middle sign. You're not going to change the sign in front of this 3. Only the sign that separates the two terms. Okay, let's distribute. 5 times negative 3 is negative 15. 5 times 3, again, positive 15, square root of 3. Underneath, it's the same process. Negative 3 times negative 3 is the same as negative 3 quantity squared, which is 9. Where it gets a little tricky is the value in front of the square root here, but the math is the same. So it's still 3 square roots of 3 squared. This becomes 3 squared times the square root of 3 squared. 3 squared is 9 times 3. 9 times 3 is 27. Got to double check. So 27 goes here, always separated by a minus. So as we simplify, we have negative 15 plus 15 square roots of 3 over negative 18. Inside of all of those values, I can pull out a negative 3. Negative 15 divided by negative 3 is positive 5. 15 divided by negative 3 is a negative 5, so this sign is actually going to change to negative. And negative 18 divided by negative 3 is positive 6. leaving this as my answer. I'm going to go ahead and erase that. There we go. Again, on the answer key, I clearly state what I'm pulling out. So pulling out -3, so you know what I'm simplifying. When you're simplifying, make sure that you're paying attention to these values. Make sure that you're pulling something out of every term. All right, number 39 and 41, they take a little bit longer because it's a binomial on top instead of a monomial like in this one. So we're going to end with more slightly challenging problems, but again, mathematically, it's nothing that you can't handle. I'm going to multiply the top and bottom by -4 minus 4 square roots of 2. -4 minus 4 square roots of 2. Kind of got in my own way here. That's okay. We'll just move down here. Give ourselves some space. We're going to have to distribute a little bit more, so I'm going to focus on the top with parentheses to make my life a little easier. 2 times -4 is -8. 2 times -4 square root of 2 is -8 square root of 2. Then I'm going to hop on over to my next piece, which is 5 root 3, and I'm going to do 5 root 3 times -4 is -20 root 3. 5 root 3 times -4 root 3 is, oh, sorry. Yes, no, I was right, sorry. See, I confused myself. Is -5 times -4 is 20 square root. 3 times 2 is 6. Okay, lots of stuff going on here. That's okay. Continuing on, we're going to do the same thing we've been doing. -4 times -4, remember it's -4 quantity squared, which is 16. I'm going to mathematically do the same thing as we did up above. 4 square root of 2 times 4 square root of 2 is the same thing as 4 square root of 2 squared. I'm going to distribute 4 squared times the square root of 2 squared. 4 squared is 16. Square root of 2 squared is 2. 2 times 16 is 32, which is how I get this number here. Okay. Again, always minus. Continuing on our trend, I'm going to have a -8 minus 8 square root of 2 minus 20 square root of 3 minus 20 square root of 6 all over -16. Between 8, 8, 20, 20, and 16, I can pull out a 4 from all of those numbers. So when I do that, let's go ahead and simplify. When I pull a 4 out, -8 divided by +4. Oh, I'll pull a -4 out, sorry. That'll give me a +2. Again, -8 divided by -4 is +2 square root of 2. -20 divided by -4 is +5 with the root 3. Same pattern here, +5 square root of 6. All over, -16 divided by -4 is 4. I know that I've simplified as far as I can because 2, 2, 5, 5, and 4 have no greatest common factors, so I'm finished. I know it seems like a lot of work, but I'm really going through all the steps here. You can definitely jump ahead. You can definitely simplify right here. I just showed that step so you can follow the video. All right, let's finish strong and let's do this last example. Multiply top and bottom by 4 plus the square root of 5. I'm going to move my math down. Again, I ran out of space here. Why don't we just start fresh? How about that? That way we have plenty of space. No one's crowding anybody. Here we go. That other one got a little messy. So 4 plus the square root of 5. 4 plus the square root of 5. Again, I'm going to distribute. I'm going to put the top in parentheses as well as the bottom, just to make my life a little easier. Square root of 5 times 4, 4 square root of 5. Square root of 5 times the square root of 5 is just 5, because 5 times 5 is 25. The square root of 25 is 5. All right, I'm going to hop on over to my next term, which is a 3. So 3 times 4 is 12. 3 times square root of 5 is +3 square roots of 5. I just have to distribute a little more. Nothing hard about it, just a little bit more math. Now we're going to simplify just like we have been. 4 times 4 is 4 squared, and 4 squared is 16. Continuing the trend, square root of 5 times square root of 5 is square root of 5 squared, which is 5. So 5 goes here. Remember, always separated by a minus. Let's continue to simplify. I have 4 square roots of 5 and 3 square roots of 5, which becomes 7 square roots of 5. 5 plus 12 is 17. And 16 minus 5 is 11. No GCFs, so I'm finished.